Hello and Assalamualaikum everyone. My name is Muhammad Zikri Hakim bin Fauzi. I'm from Mescom Group and our group will present our final project which is AI chatbot with text and voice by using MIT App Inventor. And now I would like to introduce our team members. First we have Nafis Mukri. Second we have Hilmi Lokman. Third we have Zikri Fahmi. Fourth, we have Muhammad Nur Hakim. And the lastly, we have Muhammad Zikri Hakim bin Fauzi, and it's me. And now we have a look at the background for AI chatbot with text and voice. First, this project focus on develop a simple mobile chatbot using MIT App Inventor, which is a visual programming tool that allow the app creation through drag and drop blocks. The chatbot integrates with API Gemini, a chatbot engine, and support for the both text and voice input, making it more user-friendly and accessible, especially for users who prefer speaking or having difficulties for typing. It uses the basic logic with predefined responses instead of advanced AI training, making it more suitable for beginners to learn about mobile app development, user interface design, and simple chatbot functionality. Let's move on to the demo.
Okay, for demonstration of voice input demo, first tap the tap to talk button. The speech recognizer activate and listen to your voice. Once you speak, your speech is converted into text and display. The recognized text is then sent to Gemini, the chatbot engine, and for processing. Finally, Gemini respond and the reply is displayed in the chat window. The chatbot will also speak the response aloud using text to speech. Okay, next for text input demo. First, enter your message in the text box provide. Click the send button. The message is sent to Gemini for processing. Gemini generate a response, which is then displayed and spoken. At any time, you can press the reset conversion button to clear all message and start fresh.
Two plus two equals four. 4 asterisk 5 equals 20. So the answer is 20.
Now let's take a look at the design layout of our chatbot application. This is the user interface that user will interact with on their mobile device. At the top, you will see the title chatbot, which clearly identifies the purpose of the app. Below that, we have included a text input field where user can type their questions, a send button to submit their queries, and a tap to talk button that activates voice input using the speech recognizer component. There's also a reset conversation button to clear the chat history. On the right side of the slide, you can see the component tree from my MIT App Inventor. This includes key elements like label, list view, and question tags. A critical reminder here, make sure to add a valid AI model API key and select the appropriate provider. This is essential for enabling the chatbot's intelligence. Lastly, we highlighted three core components that power this project: the chatbot component for handling AI response, speech recognizer for voice input, and text to speech for voice output.
Next, we move to the function block. First one, we have global variable. So it's initialize global checklist to create empathy list. Initialize a global variable named checklist to store the chat history. So this list is used to display message in a chat format. For the next function block, which is talk button, this allows users to interact with the chatbot using their voice. When the button is tapped, it triggers a block of code that starts the speech recognition process. Especially, it's called speech recognizer gets text which listen to the user in voice input. Once the user finishes speaking, the recognized text is captured and processed by the chatbot. So for the next blocks, we have procedure blocks, which is to process message. So for the purpose of these blocks is to add a message from a speaker to the chat list and update the list view. So what it does, first, is join the speaker and text with a colon. So next is add this combined message to the chat list. And the last one is it's update list view one element to show the latest chat message. So we move to the chatbot block. So when the chatbot receives a response from the Gemini API, a special event is triggered. This event performs two main actions. First one is it calls the process message procedure with two input, the speaker name Gemini and the chatbot's response text. This update the chat history and display the response in the list view. Second one is it use text speech one speak to read the response out loud, allowing user to hear the reply.
So for the next part of the function block, firstly, when the submit button is clicked, the app performs three main actions. First is call process message. It triggers the process message procedure with two inputs, the name user and the text from the question text input field. This allows the app to process and display the user's question in the chat interface. So for the next process, uh, it sends the question to the chatbot. The app sends the same text input from question text.text to the chatbot API or logic block to get a response. This is where the chatbot processes the user's message and generates a reply. Lastly, it clears the input field. After the message is submitted, the app sets the question text.text to an empty string. This clears the input box so the user can type a new message. So for the next part in the function block, we have speech recognizer. So the speech recognizer happens after the app finishes recognizing speech. So the action taken is the app calls the process message procedure with the name user. This step displays the recognized voice input as a message in the chat interface. Next action, the app sends the same recognized voice text to chatbot1.converse. This allows the chatbot to process the spoken input and generate an appropriate response. So for the last function block, we have reset conversation button. So how does it work? So when the reset button is clicked, the app performs the following action. Firstly, calls chatbot1.reset conversation. This command resets the chatbot's internal memory, clearing any previous context or history from the conversation. Next action, empties the chat list. The app clears the stored list of chat messages, removing all previous exchanges between the user and the chatbot. Last action, clears list view one dot elements. This removes all the displayed message from the chat interface, giving the appearance of a fresh start or new conversation. That's all for the function block.
And then lastly, for the conclusion, this project successfully demonstrates the development of a simple yet functional chatbot application using MIT App Inventor, featuring dual input modes through the text and voice. And by integrating Gemini as the chatbot engine and utilize its built-in speech recognition and text-to-speech components, the app provides an accessible and interactive user experience. Although limited to static responses and basic logic, the project provides a strong foundation for understanding mobile app development and the basics of human computer interaction. It also highlights how voice enabled technology can enhance usability and inclusivity in mobile application. That's all from us. Thank you.